Solving systems of equations algebraically, right? Who is this Al-Jabbar guy? And actually, there was a guy named Al-Jabbar who invented algebra, right? So it actually got named after him. Yeah, that's where it came. That's where algebra came from, right? There was an Arab mathematician named Al-Jabbar who came up with this idea of using unknowns or whatever, right? And yeah, we get algebra. So blame him. Okay, remember, as far as solutions go, you can have no solution one or infinitely many because we're talking about a linear system. Solve the following system using the substitution method. Okay, so the substitution method. If used properly, you got two equations. You solve one of the equations for one of the variables. So I'm going to number this equation 1 and this equation 2. So which equation shall we solve and for which variable?
We can solve the first one for x.
Yeah, the only sane choice is to solve number 1 for x. If we choose to solve number 1 for y, we're going to get fractions, right? Because we're going to divide everything by 7. If we choose to solve number 2 for x or y, there's going to be fractions, ugly fractions, right? We don't want that. So if you're going to solve by substitution, you need to find a variable by itself, right? It just has a coefficient of 1. So I shall communicate this to you. We're going to solve 1 for x. Okay. So I'm going to solve by substitution because that's what they asked us to do. And I'm solving equation 1 for x. So x is equal to what? So x is equal to. So is equal to means is the same as. Right? Means wherever you see an x, I can write what? Wherever I see an x on the board, I can write 1 minus 7y. So we are going to substitute 1 minus 7y for x in which equation? A 50-50 chance. Which equation? 2. Because if we put it into 1, we're just going to end up with something that in the end says 1 equals 1, which while true is not helpful, right? It won't solve anything. So we have to substitute the expression for the variable in the other equation. Okay, now let's keep it all on one page. So we go up here, we write 3 times 1 minus 7y plus 7 is equal to 14y. Right? So since we have made the statement that x is equal to 1 minus 7y, wherever we see an x, we are allowed to write 1 minus 7y. We now expand, so 3 minus 21y plus 7 is equal to 14y. We collect, so we've got 3 plus 7, so we're going to go 10 minus 21y is equal to 14y. We move the y's to one side, so I'm going to add 21y to both sides, right? End up with 10 is equal to 35y. So y is equal to what? Nope. Sometimes that happens, right? We just see the numbers 10 and 35 and think, oh, I'll just divide the 35 by the 10. It's wrong, but it's easy. Okay, and then we have to reduce. Very good. Okay. This caught people on the test. It said, the simplified form of the equation can be expressed as, and you expressed it and then didn't simplify it, and then got it wrong. So, what's 10 over 35? 2 over 7. Okay, so simplified or reduced form, right? We always want to go for reduced form. Don't ever write 15 over 3. The answer's 15 over 3. Yeah, let's call it 5. Okay, it's 10 over 35. No, let's call it 2 over 7. Okay, now what? Now we substitute 2 over 7 for y in either equation. I like the one that's being multiplied by a 7 because the 7s will cancel, right? So at this point, whether you've done substitution or elimination, right? In the elimination method, you just eliminate, and you get a value, right? You solve for one of the variables. Okay. Substitution method, you substitute, you solve for one of the variables. Then the two solution methods become the same. Okay, so we are going to substitute 2 over 7 4y in the modified version, let's call this number 3, in 3. Okay, so x is equal to 1 minus 7 times 2 over 7. Let's write the 7 as 7 over 1, makes things look nice and fractional, right? So that's it. And we've got x is equal to 1 minus 2, which is negative 1. And so we have a solution which is negative 1 and 2/7, right? And it's an ordered pair, right? That's the point that is on both of the original equations. How do I know that? Well, I'm going to check. Okay, and I'm not going to do a formal. Okay, I'm just going to stick in the numbers, right? So I've got negative 1 plus 7 times 2 over 7, which is negative 1 plus 2, which is 1. That one really should have worked out, right? Because that's how we got this. Okay, now, let's say we made a mistake here, right? Then substituting in here, you would have now solved a different system, right? Let's say you'd written 1 plus 7y instead of 1 minus 7y for some reason, right? You solve, I have a solution to the system. And I would say to you, you have a solution to a system, but it is not the system because you made a mistake. But if we take this and go back to the original, negative 1 plus 7 times 2 over 7 is negative 1 plus 2 is 1. You can do it on your calculator as well. 3x, so negative 3 plus 7, okay, negative 3 plus 7 is positive 4. 14 times 2 over 7, 7 goes into 14 twice, 2 times 2 is 4, right? It works, okay? Take my word for it, do it on a calculator. And you could do a formal left side, right side check, right? If you had to. Okay. I'm not doing that, right? I'm just, and you know when I'm doing this? When I'm finished the entire task and then I go back to it and just say, okay, does this work? And I'd probably just do it on the calculator, right? Just go negative 1 plus 7 times 2 over 7, enter. Hey, I got a 1, good. 3 times negative 1 plus 7 gave me a 4. 14 times 2 over 7 gave me a 4. Good, works. Questions? You know, it's like we got this last year, right? Or you're looking at this going, that's why I always got those substitution questions wrong. Solve the same system. Really? All right, what was the system? I don't even know what the system was. Give me the, what is it?
X plus 7y.
X plus 7y equals 1, and the other equation?
3x plus 7 equals 1.
Okay, so the first thing I'm going to do is I'm just going to rewrite x plus 7y is equal to 1. We'll call that number 1. I'm going to rearrange this as 3x minus 14y is equal to negative 7. Right? So I want to write it so that the x's and the y's line up. Okay? And generally when we solve by elimination, we always want it as the x, the y equals a number. The x and y equals a number. Okay, so elimination method is also known as the add or subtract, addition or subtraction. Okay, so what do we have to do? Let's call this 1, let's call this 2, let's call this 3. Because it's a slightly different form, right? And we also might have messed up going to 3. You're here to make sure that doesn't happen, but it happens, right? Okay, so what do? Elimination. We eliminate. Okay, so the elimination is also called addition or subtraction. If I add them, I'll get like 4x minus 7y, so I would not have gotten rid of anything. If I subtract them, I'll get negative 2x and then 21y. Okay, so no, so we got to do something.
Can we multiply the first one by 2?
We could multiply the first one by 2. Good choice. Or we could multiply the first one by 3. Either way, right? So there's no. So what we want to do is we want to multiply the first one. Okay. Why? Because it's got the lower numbers. If I multiply it by 3, the x's will be the same. I will subtract. If I multiply by 2, the y values will be the same, but opposite signs. And so I'm going to add, which makes life a little bit more easy, right? Okay. So we're going to take this times 2, which is going to lead to, I'm not going to say it's equal to, right? Because I already got one equal sign. So what do we get? 2x plus 14y is equal to 1.
Two.
It would be a 2. Good, because you know what mistake you're going to make? That one. Okay, that was on purpose, and you knew that. Okay, so watch out, right? The big thing is, we multiply, get the left side, we leave the right side the same, and then it just the wheels fall off, right? The problem when the wheels fall off isn't that, you're going to get it wrong. It's that you've now turned something that solves quite nicely into something really ugly that you got to spend 10 minutes on and is all wrong anyways, right? So, take more care. Okay, so RTQ, read the question, right? RTQ squared, read the question and then read it again, okay? Like, what are they saying? Are there some keywords in here? Oh, the simplified form, right? So just don't immediately assume, I got the answer, I'm done. Okay. What do they mean, simplified form? Oh, yeah, okay, I got to change this. All right, what are we going to do with these guys? We're going to add them, right? Okay, so what do we get? 5x is equal to -5, and we will all be surprised to find out that x is equal to -1, right? Unless we look at the page just above where we're writing this stuff and say, yeah, okay. You should be getting the same solution, right? All right, then what do we do with the x equals -1? So move over here and we're going to say substitute -1 for x, where? Sure. I'd go back to one of the originals, right? Now remember, at this point we have solved a system, but it might not be the system because maybe we made a mistake. But we don't know that, so substitute -1 for x in equation 1. You go into any equation, 1, 2, 3, just you start risking stuff when you're going into these guys, but at this point you've got it wrong anyways, they've made a mistake, so it's not really going to matter. Okay, so what do we got? X plus 7y is equal to 1. -1 plus 7y is equal to 1. 7y is equal to 2. And y is equal to, you better not get this one wrong, right? You already got the answer. And then we should put down the point. -1 and 2/7. Okay, so that's our solution. Then we should go back to the original equations. Nothing that we've messed with, right? So now you're going back up to, well, we don't have to do that because we already know this is the solution. But when you do your check, always go back to the original, because if you made a mistake, added when you should have subtracted, whatever, rearranged something and got a wrong sign somewhere, you're not going to solve the system. Okay? Questions? Linear quadratic. All right, new stuff, right? That was review. Ooh, it was all new to me. Never. Remember, there can be none, I don't like that wording, none, one, or two solutions. Because I don't like none with solutions, right? There can be no, whatever. There could be no solution, one solution, or two solutions. I would have used the word, whatever. Solve the following system using the substitution method. Okay, number 1. Number 2. What are we going to solve and for what?
Why?
Why? Because we need to solve by substitution.
Variable y.
In which one?
First.
Because, just give it here. Just make me think. Why? Well, because otherwise we're just so we're going to solve now, given a choice, it's a lot easier to solve the linear, right? I mean, if I want to solve for x, and I could solve for x in number 2, it's really not going to make a terrific difference, I don't think. Okay, but we will solve 1 for y. And we shall write down, solve 1 for y. If you look at my key, you're actually going to see that, right? Because I'm actually in. And I think it's a nice thing, right? Because you're communicating to whoever, right? To me, or you get this thing back and you get your written response, and then somebody else says, "Can I see your number 3?" And there's a nice solution as opposed to, "What did you do here?" Right? So, I mean, look at your solutions, and if you think I'm going to look at it and say, what did you do here? Then put a little explanation in. Just say, this is what I'm doing here, right? And it's for you more than me. I mean, well, sometimes it's for me because I really no clue what you're doing. Okay? But write it in for you. What am I doing? I'm going to solve number 1 for y. Okay, so what's y? 3x minus 2, right? So I'm going to actually kick the y to the right where it becomes positive y, subtract 2 from both sides, end up with 3x minus 2 equals y, and then write it as y equals 3x minus 2, right? As soon as it's equal, you can reverse the signs. Okay? Or I could say negative y is negative 3x plus 2, and then go through and change the signs. Okay? Whatever you like to do. I don't care, right? Just get y equals 3x minus 2. Okay, now what? Here, put a little arrow so that you can follow. Because I don't know how you're going to write this, but you know, if you look at your solution after we do this, and you sort of say, hey, if I look at this in 3 days, I'm not going to know what order I did this in, right? Like, I'm not really sure, did I go down and then I went over and have another column, right? Like, how did I do this? And that's kind of something that I might wonder, you know, and again, on a test, ask yourself, is he looking at this, because I'm not the brightest guy in the world, is he going to be able to follow what I've got here? And if the answer is no, then put little arrows in and just say I'm going down here, then over to here, and then down this and over to here. You know, if it's obvious in columns, nice, neat, laid out, okay, good. You know, I can figure that much out. All right, what are we going to do? Well, we're going to substitute. What are we going to substitute? No, we're going to substitute 3x minus 2 for what? Where? Okay, well, you're not going to substitute y for 3x minus 2, right? So we're going to substitute 3x minus 2 for y, okay? Because what have we got, right? We have now said, this statement says y and 3x minus 2 are the exact same thing, right? Where I see one, I can put the other. I see a 3x minus 2, I can write a y. I see a y, I can write a 3x minus 2. Okay, so I'm going to just rewrite 2x squared, whoops, minus x plus 2 times 3x minus 2 is equal to 8. Okay, so I have substituted 3x minus 2 for y in number 2, right? I say what I mean, and I mean what I say. Okay, next step. What do we want to do?
Expand it.
We're going to expand it, right? And then we're going to collect it, right? And we're going to show way too many steps. No, we're not. This is the right amount of steps. 2x squared minus x plus 6x minus 4 minus 8 equals 0. I'm going to just throw the 8 in there, right? Everybody okay with that line? Why is it minus 8? You know why it's minus 8, right? We're just moving the 8 over, okay? Because ultimately we know that I don't want to have some quadratic equals 8. Because at that point, some of you are going to try and solve that, and it's not going to work. Right? Or you gotta complete the square. Don't solve by completing the square, right? Unless it says solve by completing the square. That's, yeah, you know, use the quadratic formula. If you're at the point of saying I want to solve by completing the square, don't. Right? The only time you solve using what we call the square root principle is if it's in the form 2 bracket x minus 3 squared minus 17 equals 0. Yeah. Okay, because you're not completing the square. You're just moving the 17 over, dividing by 3, taking the square root of both sides, remembering that the square root of the right-hand side will be plus or minus, right? So you get 2 solutions, and away we go. All right, what does this become? 2x squared, what? Plus, minus. All right, well, one can only hope this factors, right? So try factoring it. Your first step, okay? If that was a plus 4x, I would divide everything by 2, right? Because I can't. Why? Because the right-hand side is 0. I can divide everything by, I can't. We're not going to do that. Doesn't make sense. Okay, so factor it. It's got to be 4 and 3, right? It's a 2x and an x and a 4 and a 3. Because with a 4 and a 3 and a 2, I can make a 5. Okay, factor it. Then check your factorization. Make sure that your signs are correct. Make sure that you get the right middle number. Make sure that the middle number you get is positive. Make sure that you get a negative for the last number. Make sure you write equals 0. Don't look up until you've checked your own. And let me just check my own. Things for plus 8 minus 3. Yep. Don't gloss over it, because if that's wrong, then everything beyond that is wrong. Yeah, which in this case is really just the answer. But in further work, that solution that you use then gets used somewhere else and gets used somewhere else, and it cascades on down. Okay, so what's x equal to? 3 halves? Or? -4. Okay, now we know that there can be no solution, or one solution, or two. Potentially we have two solutions here, right? Because we have two values of x. So, now we say, all right, so hang on. So this, we went down here, we're going back over here, because, you know, I'm sure you can lay this out a little better on your paper, you got more room or something. What do we know? Okay, so we're going to say when x equals 3 halves, what? Well, we're going to have to put it into 1 or 2 and solve for y. There's only one of them that it makes sense to put into, right? Which is what? There's more than one. I'm thinking 1 is, I think it's a little less work if we put it into 1, right? Because we only have to put it in once. You put it into 2, you're putting it in twice. I don't know. Okay, so what do we got? 3x, so 3 times 3 halves. I'm going to write the 3. So 3 over 1 times 3 over 2. I just do that so I've got denominators, right? And if something's going to cancel, or I don't lose stuff, whatever. So that's 3x minus y is equal to 2. So we've got 9 halves minus y is equal to 2. So I can go y is equal to 9 halves minus 2, which is 9 halves minus 4 halves, which is 5 halves, giving me a solution of 3 halves, 5 halves. And there should be another solution, right? X equals -4. I'll go down here, and we come back up here. I'm sure you can arrange this much better on your page. So when x equals 4? -4, thank you. I was distracted by an email notification. Which I should turn off, because... Oh! When x equals -4, what have we got? 3x minus y is equal to 2. -12 minus y is equal to 2. Negative y is equal to 14. So y is equal to -14. So 4, -14. All right. Is this true? How do we find out? Got a couple of ways, right? When are you going to do this? You do it when you have finished the entire test, when you have gone through and made sure you've got solutions to everything, and only if you have time to check will you then go back and check, right? And you want to say, okay, let me go check. So you just go in, so we go 3 times 3 halves, which is 9 halves, minus 5 halves, so 9 halves minus 5 halves is 4 halves, which is 2, okay? So this works here, and then we go 2 times, well, you might want to use your calculator, right? So we go 2 times 3 halves squared. So 3 halves squared is 9 quarters, times 2 is 9 halves, minus 3 halves is 6 halves, which is 3, plus 2 times 5 halves, which is 5. 3 plus 5 is 8. Okay? Trust me, it works. I know you're just saying stuff. Okay? Then we put in a 4, -4. Wow. -4. Then we put in a negative 4, so we've got negative 12 minus negative 14. So negative 12 plus 14 is 2. Okay? And then we go negative 4 squared is 16, not negative 16, right? Negative 4 squared is 16 times 2 is 32 minus negative 4, which is 32, plus 4, which is 36, plus 2 times negative 14, so 36 minus 28, which is 8. Okay, right? And you're just sitting there going, you're just talking stuff, right? So how would you do it yourself? Just go in and just punch them in, you know, whatever, right? And this presumes you're finished the test, you've checked other easy stuff over, right? I mean, you know, what's the loss of mark? If you got these guys wrong, you're maybe going to lose a mark, right? It's like, you messed up on your signs here, and you're just, you know, you got wrong stuff. Okay, questions? So it's a linear quadratic, right? A straight line, and we've seen from yesterday, we could have no solution, you know, you might just get it and say, I can't solve this, right? Or one solution or two. Solve that, really? Seriously? Wow. Really? Oh, wow. It's like we're trying to prove a point or something. It's like, come on, man, let's solve it. All right, we know what the solution is, right? So, you know, if we get something different, you're never going to do that, right? I mean, you don't solve something twice, you know, especially once you've checked it. Okay, what are we going to do? Got 3x minus y equals 2. So what I want to do is to be able to add or subtract the equations and end up eliminating, because it's the elimination method, either x or y. Not both, because you just won't solve, right? You can't. So what are we going to do? Yeah, multiply the first one by 2, right? Because then we get to add. It's always nicer adding. Okay, when you subtract, the problem that happens is you end up with like, I got negative 8 minus negative 4, and then you mess up. So we don't want to mess up. All right, so we are going to take 2 times 1. 6x minus 2y equals 2. It's 4. Oh. Come back. My pause, pointed at my wand. Right? That's the mistake you're going to make. Okay? Trust me, I've been watching students make that mistake for 20 years. I know what's going to happen. Right? So just make sure you're multiplying everything by. Okay, and what do we got? 2x squared minus x plus 2y is equal to 8. What are we going to do with them? We're going to add them. Right? So if you have opposite signs, you add. If you have the same signs, you subtract. Okay, so we get 2x squared. There has to be an x squared, right? Because there has to be 2 solutions. We already know there's 2 solutions. Initially, we maybe not know that, but now we know there are. Okay. All right, so what's 6x plus negative x? Plus 5x plus 0 equals 12. So 2x squared plus 5x minus 12 is 0. Okay, we end up with that. All right, so we're done, right? We're done. The rest of it just follows. Okay?
Skip it.
Yeah. Once we've got this, the solution method is the same regardless of whether you're doing substitution or elimination, right? Yep. Okay. Let us know what you decide on. So it's the same, right? At this point, it's the same. So there's no point in redoing what we've done, right? The same as, is it above or to the left or to the right or on the previous page? Or same as on the previous page. The same, which works for both of us, right? Because for us, for me, it's the same as on the previous page. The same solution as on the previous page. So I think the point is just showing you, it really doesn't matter. It's going to come down to a quadratic. It can't be a different quadratic unless it was in y, right? If we had a y squared or something, then getting the 2 y values, but that's not going to happen. Quadratic system. Remember, there can be no solution, one solution, two solutions, or infinitely many solutions. Solve the following. Is number 6 to do the same thing with elimination?
Yes.
Of course it is. All right, but you know, well, I don't know. I don't know where this is going. Let's find out. All right, so what are we going to solve, and what are we going to solve it for? Here, this is 1. This is 2. All right, so we're going to say solve for, okay, solve what? For what? Solve, yeah, solve 1 for y. You could have solved 2 for y. It's not going to make a huge difference, right? You're still going to end up with a quadratic. You're still going to get the x values, whatever. But 1, I think, is just a little bit easier. Okay, so what's y equal? So I'm going to leave you, do as much work as you need to solve 1 for y. And I want you to come up with a line that says y equals something. Okay, so do that. Come up with a line that says y equals, and whatever you think y should be equal to. I'm going to write something up here that may be right, but it may be wrong. Yep. Sure. Okay, so
Oh, that's just supposed to be.
yes, no, maybe so.
Um,
Good. Hey, so we're done after number 6. Eh?
So repetitive.
The end is near. Okay, now what? Okay, so I'm going to say we're going to substitute 6x squared minus x plus 1 for something in something. For y in 2. Okay, so you got to put it back into the other equation, because if you stick it into 1, you're going to end up with -1 equals -1, which is quite true, but not at all helpful, right? Because it's just, wow, I have a true statement, but I haven't actually solved for anything. Okay, and I'm going to move up to here just in the interest of keeping it on one page. And I don't know if you've got room, but somewhere you'll squeeze it in. Okay, so what do we got? 4x squared minus 4x minus, you will now put down a parenthesis, right? Because the expression you're substituting needs to be subtracted from. And we're going to need to use the distributive law. And if we don't put a parenthesis down, then it's just going to be wrong. Plus, you're right. Not done on purpose. The surprise. Oh, good though. Good catch, right? It's your job. If you learn the stuff, that's good. But if you make sure the video is correct, that's better.
So 5 people that watch it.
So yeah, some kid in India is going to be watching this, and they're going to be saying, "That's wrong. What happened to the plus 6? What went on?" And I got to put a little bubble in there that says, "Whoops, there should be a this there." And I don't like doing that. Okay, so 4x squared minus 4x. Okay, you expand the rest of the line. And once you've done that, then look up here and see if I did it correct. Okay, yep. Yeah, I wasn't trying to make it. I'm trying to do this right. So the big thing is, right, if you don't put your 6x squared minus x plus 1 in brackets, you're going to get it wrong. Right? So you have to, because it's being, so if it was added, it's, okay, it's not going to make a big difference. right? But if this were like a minus 3y, you'd need that because each term would have to be multiplied by negative 3. Okay, for those of you watching on video, I'm just waving my hands in the air while I say that. Okay, so what do we got? Negative 2x squared. What's next? Minus 3x plus 5 is equal to 0, right? So as soon as I see that, I'm going to write 2x squared plus 3x minus 5 is equal to 0. So one was a parabola opening down, and now it opens up, but it doesn't matter because it has the same x-intercepts, and all we care about is the x-intercepts of the graph, the zeros of the, what is it? Or the roots of the equation, the zeros of the function. Right? Okay, does this factor? I don't know.
Yeah.
So, well, if it does, the 5's got to go there. So we need a plus, minus. Okay, 2x squared. Minus 2 plus 5, yeah. So here's the thing. You're solving one of these and it doesn't factor, you seriously go back and run through your steps. Right? And then you just say, I'm going to leave this and I'll come back to it later. And then you come back to it later and you run through your steps again and you say, wow, it really doesn't. Then you graph it and you check and make sure that they round, right? Or I mean, if it says rounded to the nearest hundredth, then you know, oh, there's a shot that this doesn't factor, right? But generally speaking, we're not going to do that to you, right? Because you got to go back and you got to substitute in negative 5 halves and 1 for x and solve for y, and you know. So if things start to get really weird, like this is nothing like anything we've done, and this is a lot of work, and I need to turn the page sideways so I can fit the thing in, because it's, you know, then you should at that point, what I would do, I would stop and go on and just do other questions, right? Like I think I might have taken the wrong track here. And maybe not. Maybe it really is going to work out that way. Okay, but then you just got to think, we didn't do anything that bad to him recently, so why is he trying to do this to us? We don't. What's x? 4? So we done? That's it. I got 2 values of x. Done.
We have to.
We're going to stick the 5 halves, negative 5 halves in, and the 1 in. All right, where are we going to put them? I'm very tempted to just go with this. Right? Like, if it's wrong, so is everything else at this point. Really, right? You know, seriously, if you got that wrong, it's all wrong anyway, so, yeah, what have you got to lose by, you know? So it's kind of the simpler equation, right? So it's in the form y equals, so it's just going to give us a y value, right? We plug in an x, we're just going to get our y value. Okay, so we're going to substitute. Negative 5 halves. 4y in 4x, you're right. I just think, let's number that, 3. 4x in 3. Okay, y equals 6 times negative 5 halves squared. Don't worry, we get to do this by elimination. Minus negative 5 halves. Plus 1. Really? 25 quarters and 6. Okay. 6. At this point, I am asking, what did we do? What did I do to deserve? Who made up this worksheet? Plus. Oh, everything's got to be changed to quarters, right? Oh no, that's not true. So 4, so 2 goes into that twice and into that 3. So we get 75 over 2 plus 5 over 2 plus 2 over 2.
What?
Well, 1 is 2 over 2, right? Okay. I need a common denominator. I'm going to be allowed. What is that? 82 over 2? Let's call that 41. Some of you will leave it as 82 over 2, and I'll circle it and go, really? 41. Well, okay, that's not so bad, right? Where are we going to put that? The solution set. So what do we got? Negative 5 over 2 and 41. Nice 41. Okay, substitute. Well, this one should work out nicer, right? 1 for x in 3. So y is equal to 6 times 1 squared minus 1 plus 1, which is 6. So we've got the point 1, 6. Really? Like, seriously, that's what phones sounded like. They actually had a physical bell in them, right? Like, really, it was like two little things, and if you wanted to quiet it, you had to take the thing apart and put a little piece of paper in there. Which was the premise of, was that Dr. Strangelove? Or some movie about it was like a teletype machine and a piece of paper fell in, so you didn't hear the bell go off, so you didn't know that it wasn't a drill. And
Substitution.
okay, so,
Solving it.
what are we putting in? Oh, oh God, yeah, I don't know, check it. Yeah, well, you know the easiest way to do this, right? So you've got y equals 6x squared minus x minus 1, and you've got y is equal to 4x squared minus 4x plus 6. So seriously, graph the two of them, look for the intersection, see if they're the same, right? Like, I would verify this graphically. Although the 1 and the 6 isn't bad, right? You put a 1 in here. 6 minus 1. Yeah, we're going to mess that up, right? Plus 1. Yeah, 6 minus 1 plus 1, so I got 1, 6. And I would put a 1 in here and get 4 minus 4, 0 plus 6. So 1, 6 works for both of them.
Would there ever be a chance where it doesn't work for one?
Yeah, you made a mistake. That's the only way it doesn't work for both of them, right? Is you made a mistake. So at that point, you just say, I'm just going to erase everything. No, you look at the time and you say, and then you write a little note saying, I know this is wrong, but I've run out of time. So there's nothing I can do at this point. And I'll say,
Except
good for sharing, thank you. And here's your 2 marks out of 5 or whatever. 1 out of 6, I don't know, whatever. Depends what you got. All right, so really, solve by elimination. All right, so yeah, hey, they are what they are, right? So let's rearrange this. If I'm going to do this, right, we'll go 6x squared minus x minus y minus 1 is equal to 0. Actually, no, you know what, we'll leave that. Equals negative 1. And we'll go 4x squared minus 4x minus y equals negative 6. Okay. Well, so okay, we maybe should have just left the numbers equal to 0, right? Because then the others, yeah. Let's do that instead. Get your erasers out. Doesn't matter. So let's go plus 1 equals 0 and plus 6 equals 0. Okay, add or subtract? Subtract, right? The signs are the same on the y's, right? And the y's are the same, so we don't have to multiply anything. All right, I got a y, minus y, I got a minus y. Okay, so we're going to subtract 6x. If you know you're going to subtract, you may want to put the larger x squared on top. Okay?
Oh, because it's minus 1.
It doesn't matter, right? If we ended up with negative 2x squared, then we would just go through and, you know, how far are we going to take the solution anyways, right? Just the next one. Okay, what do we got? 2x squared. Negative 1 minus negative 4 is? 3. What kind of a 3? A plus 3, right? Plus 3x. Negative y minus negative y is 0. 1 minus 6 is? And that's equal to 0. And is that 2x squared plus 3x minus 5? There.
Yeah.
Okay, so then the solution is the same. So you can just sort of like draw an arrow and say, look down here, right? And I'll just say, see previous page.
Elimination is so much.
So what this is saying is, well, let's say 2 things. Number 1, never use substitution unless you have a single variable by itself that you can substitute for. Never use substitution if you're saying, oh, I'm going to divide by 2, and now I've got a 5 halves, and I've got a 7 halves, and fractions all over the place. It's not going to go well. Okay? It should solve, right? But it's not going to, because you're going to make mistakes. So, to use elimination, it doesn't matter, right? Whether we use substitution or elimination in solving this problem, we are getting the same quadratic, and the method of solution, once we have the quadratic, is the same for both methods. Questions? Comments?
Two guys sword fighting on the board.
Yeah. And pi, because it's almost pi day, so I wrote pi in blue up there. But I think I can go further, but I kind of figured out. Maybe 120 decimal. Yeah, I should know one. Problem is, writing it and saying it are two different things. Like, writing it takes a lot more work. Just saying it is easy, right?
How many like digits do you know?
I don't know. Let's see.